Greetings to my dear students. So in this video, we are continuing the problems in Cauchy's theorem and problems involving Cauchy's theorem and Cauchy's integral formula. Okay. So next problem is evaluate integral over C sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 dz, where C is the circle mod z equal to 3. Okay, so here in the numerator denominator part, instead of z minus 1 or z minus 2, some z minus z naught, we have two terms, z minus 1 and z minus 2. So we have to split this as z minus 1 plus some z minus 2. So what we need to do, we have to do the partial fraction. Okay, so partial fraction for this one. So sin pi z square plus cos pi z square divided by z minus 1 into z minus 2 is equal to some a by z minus 1 plus b by z minus 2. Already we have seen problems regarding partial fractions. So this is equal to a by this and b by this. Okay, so we need to find the value of a by b. So therefore this term will split into two terms. Okay, so next we are taking the LCM. So therefore we get a into z minus 2 plus b into z minus 1 divided by this. So this 2 will get cancelled. So remaining thing we got a sin pi z square plus cos pi z square equal to a into z minus 2 plus b into z minus 1. Okay, so our ultimate aim is to find the value of a and b. Okay, for now. Okay, so how we can find the value of a and b? When we substitute the value 1 for z equal to 1, b will vanish. When we substitute the value for z equal to 2, a will vanish. Okay, so when we substitute the value z equal to 1, b will vanish. So we get the value of a. So when we substitute z equal to 1, the left hand side becomes sin pi z square 1 square 1. So sin pi cos pi z 1 z square, again it is equal to cos pi, it is equal to a into 1 minus 2 minus 1. What is the value of sin pi? We all know that sin n pi, in general sin n pi is equal to 0. So sin pi is always 0. So cos pi, what is the value of cos pi? We know that cos pi is equal to minus 1. What is the general formula? Always remind this, keep it in your mind that sin n pi is always 0. Okay, for any values of n, sin n pi is always 0. Cos n pi, okay, cos n pi, the general formula is minus 1 the whole power n. Okay, it's not looks good. Okay, okay, sin n pi. Okay, so instead of right, I am writing, instead of the symbol, I am writing PIE. Okay, sin pi. Okay, sin pi is equal to 0. Okay, always sin pi is equal, sin n pi is equal to 0. Cos n pi is equal to minus 1 the whole power n. Okay, cos n pi is equal to minus 1 the whole power n. So here we have n as 1, isn't it? Because we have cos pi. So cos pi means, sorry, this is cos. Yeah, cos n, the value of n is equal to 1. So when we substitute the value 1 here, you get minus 1. So cos pi is equal to minus 1 and sin pi is equal to 0. Okay. So it is equal to a of minus 1. So therefore, the value of a is 1. So now we find the value of b. So when we will get the value of b, and we substitute the substitute 2 in the place of z. Okay, for yeah. Okay, if we substitute the value of 2 in this place, 2 minus 2 will become 0. We get the value of b. So therefore, sin when z equal to 2, Sin pi 2 square 4. So sin 4 pi plus cos 4 pi is equal to a will become 0, b into 2 minus 1, 1. So sin 4 pi, always sin pi is n pi is 0. So sin 4 pi is 0. Cos 4 pi is equal to, by the formula we get minus 1 the whole power 4. As cos n pi is equal to minus 1 the whole power n, cos 4 pi is equal to minus 1 the whole power 4. So minus 1 the whole power 4 is equal to 1. So therefore we get b as 1. Okay, so the value of A is 1 and the value of B is 1. Now we are substitute the value of A and B in which place? In this place. Sin n pi z square plus cos pi z square divided by z minus 1 into z minus 2 is equal to 1 by z minus 1 plus 1 by z minus 2. So next, what we need to do, we have to take integral on both sides. So therefore, integral over c, the things in the left hand side is equal to integral over c 1 by z minus 1 dz plus integral over c 1 by z minus 2 dz. Okay. Okay. So now we split the given integral into two integral. Now we are going to find the values of two integrals separately, and then we add the value. We will get the original value of the given integral. Okay. So now first we consider the first integral in the RHS. Okay. The first integral is what? 1 by z minus 1 dz. 1 by z minus 1 dz. Here, what is the value of f of z? F of z is equal to 1. What is the point? In which point the analytic fails? At the point z equal to 1. So now next, we have to check the point lies inside or outside the circle. What is the circle given here? Mod z equal to 3. Okay, mod z equal to 3. So this is a circle given. So the point 1, of course, it lies inside the circle because mod z equal to 1, which is less than 3. So therefore, the point lies inside the circle. So therefore, by Cauchy's integral formula, integral of this equal to 2 pi I into f of 1, as f of z equal to 1, f of 1 is equal to 1, which is equal to 2 pi I. So next we consider second integral. So in this integral 2, the value of f of z is 1. And the point 2 in where the analytic fails lies inside the circle because 2 less than 3. So therefore the point 2 lies inside the circle. Again, we are using Cauchy's integral formula. We get integral over 1 by z minus 2 dz is equal to 2 pi I into f of 2, as f of z equal to 1, f of 2 is equal to 1. So we get 2 pi I. So we found the value of the two integrals separately. Now we are going to add the value of two integrals so that we get the value of this integral over c, this one we will get. Okay, so therefore integral over c sin pi z square plus cos pi z square divided by z minus 1 z minus 2 dz is equal to integral value of first one, which is equal to 2, which is equal to 2 pi I and which is equal to 2 pi I. So therefore 2 pi I plus 2 pi I is equal to 4 pi I. Okay. So here we have used only the Cauchy's integral formula, not Cauchy's theorem, because all the points via the analytic fields lies inside the circle. So we used only the Cauchy's integral formula. If it is lies outside means we can use Cauchy's theorem. Okay. So we will see the remaining problems in the next video. Thank you, dear students.